In section 1.1, we talk about the real number system. And so how do we classify real numbers? So let's start at the bottom of this chart. We're going to start with natural numbers. These are the numbers that we learn as a kid. These are the counting numbers. So that's like 1, 2, 3, 4, 5, keeps going on up. Now, natural numbers can be extended into whole numbers. So the difference between natural and whole numbers is whole numbers now includes 0. So this is just the natural numbers. Plus 0. That's the only difference. So we start at 0 and then we go up the number line 1, 2, 3, 4, and so on. Now we're going to add on a little bit more. Integers are what you would see on a number line. So we still have the whole numbers that are involved, but what we're adding is the negative of those numbers. So that's going to be our whole numbers. Plus the negative of those whole numbers. And so now we can have -4, -3, -2, -1, and then we start adding those whole numbers back. 0, 1, 2, 3, 4, and so on. Now, what are rational numbers? So rational numbers includes all those integers we just talked about, but we also have fractions. So we have integers plus fractions. That would be things of the form a over b. Plus decimals that end. So that would be something like 0.125. And plus decimals that repeat. So like 0.6666, and it just keeps going forever and ever. So there's a lot that is involved with rational numbers. So if a number is not rational, then it falls into the irrational category. So things in this category would be non-terminating, and non-repeating, decimals, this would be something like 0.1, 2, 3, 4, 5, 6, 7, 8, 9, and that just keeps going with no distinct pattern, and it doesn't end. We also have non-perfect square roots. And one more thing is any number that has pi in it. So some examples, some non-perfect square roots would be like the square root of 5. And anything with pi in it could be like 2 pi. And then what we have at the top that encompasses all of these, irrational, rational, integers, whole numbers, and natural numbers, is the real numbers. And so you can kind of see the hierarchy with the chart. So now that you kind of understand what each category involves, let's place all of the following elements in the appropriate classifications. So let's go ahead and just take a look at the list first. We've got 5, we've got square root of 5. Well, square root of 5, that's a non-perfect square root. So I think we know where that's going to go. We've got -11, we've got 0, we got 4 and 1/7, we got -6/3, which can be simplified. Let's go ahead and simplify that. That's -2. And we got 2.2 and the square root of 16. Well, 16 is a perfect square, and so we can actually simplify this one, and we end up getting 4. So now that we've simplified what we can, let's go ahead and put it in the correct spot. Let's start with 5. Where would we put 5 down? Well, 5 is one of the natural numbers that we learn as a kid. 1, 2, 3, 4, and 5. So that means it's going to go into the natural number. It's also going to be a whole number. It's also going to be an integer. It's going to be a rational number. Which also means that it's a real number. So 5 is done. What about the square root of 5? Well, I kind of already told you. That's going to be an irrational number because that is a non-perfect square root. But just because it's irrational doesn't mean it's a real number, so it's also going to be a real number. What about -11? Well, that can't be a natural number because we don't talk about negatives there. And it's not a whole number because we still don't have negatives. So that has to start at our integers. So we got -11. But that also means that it's going to be a rational number. And again, that's going to be a real number. What about 0? Is 0 a natural number? No, and a lot of people get that one wrong. 0 starts at being a whole number, which also means that it's an integer, which means that it's a rational number, and again, it's a real number. 4 1/7. Well, that's definitely not one of the numbers we learn when we're a kid, and it's not a whole number, and it's not an integer, so it's got to start at being a rational number, which means that it's also a real number. Almost done. We have -6/3. That's -2. And so that's not a natural number. It's not a whole number, but it starts at an integer. So we got -6/3, which is also a rational number, which is also a real number. Gonna sound like a broken record by the time I'm done. We got 2.2. Well, that's a decimal that ends. It terminates. And so that's going to start at a rational number, which is also a real number. And the last one is square root of 16. That simplifies to be 4. And so that is a natural number, which means that it's also a whole number, which means that it's also an integer, which is a rational number, and finally, it's a real number. So now I think you understand where numbers fall in this hierarchy. Let's talk about the properties of real numbers next. And so we've got 5 major properties. We have the commutative, the associative, the identity, the inverse, and the distributive property. So the commutative property, this deals with the order of things. So when talking about addition, this just says that A plus B equals B plus A. It doesn't matter the order in which I add, I will get the same number either way. So that's like saying 3 plus 4 equals 4 plus 3. We end up getting 7 regardless. Same thing goes for multiplication. This just says that A times B equals B times A. Or 3 times 4 is the same thing as 4 times 3. We get 12 in both cases. So commutative just says that we can multiply or add in any order and it doesn't mess anything up. The next thing is the associative property, and this deals with the grouping of things. So when we're talking about 3 numbers, if I have A plus B plus C, where B and C are added first and then we add A, that's the same thing as adding A and B first and then adding C. So that's like saying that 2 plus 3 plus 4 is the same thing as doing 2 plus 3 and then adding 4. We end up getting 9 in either case. The same thing goes for multiplication. So if I were to multiply B and C first and then multiply by A, that's the same thing as multiplying A and B first and then multiplying by C. So 2 times 3 times 4 is the same thing as 2 times 3 times 4. We get 24 in either case. The identity property. This means that it keeps it the same. Now we have two different things for this property. When we talk about multiplication, the identity is 1, and when we talk about addition, the identity is 0. So if I were to add 0 to a number, I would get the original number. So that's like saying A plus 0, that's equal to A. 3 plus 0 is 3. It doesn't change the number when I add 0 to it. Something similar happens when we multiply by 1. That's like A times 1 gives me A. 3 times 1 is going to give me 3. When I multiply by 1, it doesn't change the original number. For the inverse property, the goal is to give the identity. So when we talk about addition, the goal is to get to 0. So that means A plus negative A would give me the identity of 0. If I said 3 plus negative 3, that gives me the identity of 0. For multiplication, when I multiply A by its reciprocal, which is 1 over A, I get the identity of 1. So 3 times 1 over 3 gives me 1. And then the distributive property. This says A times B plus C, that I can distribute A to both pieces. That means I have A times B plus A times C. So 2 times 3 plus 4. Instead of adding the 3 and 4 together first and then multiplying by 2, I can just distribute and do 2 times 3 plus 2 times 4. So now let's state the name of the property that justifies each statement. We've got 5 plus 7 plus 1 equals 5 plus 7 plus 1. Well, the only thing that changed was the grouping. And so because the grouping changed, this is the associative of addition. What about x plus 0.6 equals 0.6 plus x? So what changed on this one is the order. And so that means that this is the commutative property. of addition. We've got 5 times y equals y times 5. Well, again, what changed here was the order. But now I'm dealing with multiplication. So this is the commutative property of multiplication. What about 6 times 1 over 6 equals 1? Well, this ended up giving me the identity. And so then this is the inverse of multiplication. And the last one, we got 5 times 9 plus 3 equals 5 times 9 plus 5 times 3. Well, this is the distributive property. You can see that I brought 5 into 9 and 5 times 3. And for the last two examples, we're going to talk about inverses. So remember that the goal of the inverse is to give me the identity. So when we talk about the additive inverse, we want to get to 0. So what can I add to negative 12 to get to 0? Well, negative 12 plus 12 would give me 0. And so 12 is the additive inverse of negative 12. What about the multiplicative inverse of negative 5/3? Again, the goal is to get to the identity. Well, the identity when we multiply is 1. So what can I multiply negative 5/3 by so that I can get 1? Well, the way the inverses work with multiplication is we use the reciprocal, which just means that I flip the fraction. So it's now negative 3/5. And we can check that because when we multiply across the top, negative 5 times negative 3 is 15. And when we multiply across the bottom, 3 times 5 also gives me 15. And 15 over 15 is 1. And so the multiplicative inverse of negative 5/3 is negative 3/5.